Okay. 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 So we were discussing uh, constructors, destructors, and object lifetime. Okay. So let us go to this example. So we were looking at this example where our sort of tried and tested example of stack, where we saw that using constructor, your user program becomes very, very simple, because all you have to do here is you have to just instantiate the stack object. Okay, and then the constructor would automatically do the needful. Okay, so in this particular case, uh, if you are using an automatic array, let's say, so the only thing that needs to be done is top needs to be initialized to -1. Okay, but in other cases, you may also want to do, for example, if you are using dynamic array here, you may want to also allocate memory for the data array, or so data array, and you can do that also in the constructor. So you can initialize the data array with using this new char 10. Okay, so it will basically construct a new character array and initialize this data member, uh, char star underscore data with this new character array. Okay. Uh, okay. So till now, okay. And then the user program becomes very, very easy. Okay. So what are the other things? So let us look at some of the, so as you can see, it looks as though the constructor is a member function, right? So actually, uh, we had also looked at this particular thing where the constructor was defined inside the class. But just like you can define the member function outside the class, you can also define the constructor outside the class. So this is what I'm showing here. So you have to basically mention the class namespace, which is the stack : and then if you, sorry, okay, I don't know what happened. Okay, so yeah, and then you can simply define this constructor. Okay, so this is the other thing. Okay. Okay, so here are some comparisons between the constructor and general member function. So just like a general member function, the constructor also has access to this pointer. Okay. Um, Here, the name is, of course, fixed. The name has to be the name of the class. Okay. Now, this is a major point of difference, that the constructor does not have any return type. Okay. So this is important to understand, that it does not even return void. Okay. Uh, so, um, okay. So this is one of the important things, both constructor and destructor. Okay. The other thing is that constructor actually does not return anything. Okay, so the way the constructor operates is that it so in a sense you can say that the constructor returns the object that is being constructed. So that is already given. Okay, so constructor is called when a particular object is constructed, and the return value of the constructor, okay, that expression is the object being constructed. Okay, so there is no return type, because the return type is in a sense fixed, which is an object of the same class. Okay, and uh, another thing is that since there is no return type, so there is no return statement also. Okay, so in the body of the constructor, you cannot write any return statement. Okay, because nothing is being returned. Okay, so you remember even in functions which return a void, you still have to write a return statement. Okay. Okay. So this is this is kind of a major difference between constructor and normal member function. The other difference which we discussed yesterday was that the constructor can have this initializer list, okay, which the other member functions cannot have. Okay. Um, then call to the constructor is implicit, whereas other member functions you have to call explicitly. Okay, and other things are same. You can have parameters in constructor just like you can have parameters in other member functions. Okay, and those can also be overloaded. Okay. Okay, so here is an example of a parameterized constructor. Okay, so we are creating this class complex, and then we are creating the parameterized constructor, which has two inputs. One is this real, and one is this imaginary, and basically what it does is it uh, it sort of yeah, so it initializes this RE, so the data member RE underscore with RE, and the data member IM underscore with IM. Okay. uh, yeah. Okay. Yeah, and there are other member functions you can have. Okay. And yeah, so you see here you are and both forms of initialization are possible. Okay, so this is this is the functional form of initialization. Okay, and this is the this is the old you can say C style initializer, or initializer list type of initialization. Okay, and both of these are valid, and both of these call the same constructor. Okay. um, okay, so so this is clear. Okay, now okay, you can also have constructor with defaulted parameters. So actually this might be one of the very common ways of defining constructors, where, for example, in this case, it's very natural to define to have two arguments, but also have some sort of default value for the two arguments. So then what happens is that you can initialize complex numbers with basically both the real and the imaginary component, or you can initialize it with only the real component. Okay, or you can just initialize with it without any parameters, in which case you just get all the default parameters. Okay, and you can see, okay, all of this. Okay. Okay, so I think this is clear. Yeah, so again, another example of constructor with default parameters. So, okay, so here, basically you are taking the sort of the size of the stack. So this is the stack example we are going back to, and you are taking the size of the stack as input with a default value to 10. Okay. And then basically you are just allocating that much array for size, and then you are working with this. So basically, if you can have a usage like this, where you can see that, suppose you already know that you have to reverse a string str which is already known to you, let's say, then you can simply pass the length of that string as the parameter to the stack. Okay, and it will create the stack with just enough memory to perform this operation. So it will not utilize any extra memory or anything. Okay. Uh, Okay. Now we can also have overloading of constructors, like we saw. Okay, and here are some examples of the overloaded constructors. Again, for the complex example, you can have constructed with both the real and the imaginary, or only the real and imaginary set to some value, or with no parameters. Okay, so we will come that this constructor with no parameter is a special thing which is called the default constructor. Okay. Okay, so so I think this is clear. Any questions or comments?
Sir, will it not be same if we do double R equal to 0 and double IM equal to 0 in the first method?
Yes. So in this case, it will exactly be the same. But there may be situations where you want a different behavior for different types of arguments. Okay. So in that case, the function. So basically, you get to yeah. So if you need a different function body, then you have to overload, right?
Yes, sir.
Okay. Okay. So okay. So now we go into the other thing. See, we go back to this example where we were doing this array example. Okay. Sorry, the stack example. Okay. And you see, we had the constructor, and the constructor was actually defining the constructor was doing something, and one of the things it was doing is it was allocating some memory for this data. Okay, which is a normal thing to do. Now, what happens if if you create an object of type stack? Okay, and then you use it, and then after a while you don't need it. Okay, so then what happens to this particular piece of memory? Okay, now note that by default, even if this stack object is destroyed or deallocated. So what is the stack object? The stack object is basically having these two data, right? So it has basically one pointer to character and one integer. Okay. So even if you if your, let's say, this stack object is no longer valid or does not have any memory. So for example, suppose you have created it inside a function and that stack frame has been destroyed, or otherwise. We'll see in the lifetime what are the ways you can create objects. Okay, but essentially what happens is, see, this allocation, the data member which was allocated dynamically, this still does not get destroyed. Okay, so what you have to do, you have to then write a function something like dinit. Okay, which you will have to call just before returning from this function. So in this case, it's the main function. Okay. But it could be that, I mean, you can very well imagine that this stack object was being created inside another function. Okay. And then there will be a memory leak. Okay. Because and that function may be called many times. So there will be a lot of memory leak in that case. Okay. So you have to call before exiting the dinit function to actually delete this particular data member that you allocated. Clear? So now the thing is that this is a very bad coding practice, right? Because what if, this is the application programmer's code. Okay. So the programmer may just so it's a sort of a headache for the programmer to actually remember to deinitialize every time. Okay, so for this this is one situation where you need the destructor. Okay, So again, the destructor is like,
Sir?
Yes.
Sir, can you please explain how there is a data leak with the DInit?
Okay, so suppose imagine that you are creating this stack object S inside some other function. Okay, so when that function return, what will happen? This stack S will no longer will be destroyed, right? So will be deallocated and destroyed, right? Because that particular stack frame no longer exists. Okay, but at the time of at the time of constructing this stack object, we had allocated memory. This memory was not in the stack. This is a new memory. We are using new here. So this is in the free store. Okay. So when the stack object gets destroyed, okay, this piece of memory will not be deallocated. Clear?
Yes, sir.
The source of the memory.
Yes, sir. But the only problem is in the DInit, right? If we call every time DInit, then it is fine.
Yes. So if you call DInit every time, then it's fine. But that is not a good,
Yes,
that's
sir. Got it.
technique for the programmer. Okay.
Yes, sir.
But now, so how to, so the destructor basically provides you a mechanism by which you don't have to explicitly call this DInit. Okay, so here we are showing that mechanism. So the mechanism is basically that you define this destructor. Okay, so the destructor, as we discussed earlier, is basically a function or a member function which is tilde followed by the name of the class. Okay, and destructor does not have any parameters. Okay, and it does not have any return type. Okay, so and also the destructor is called implicitly when an object is destroyed. Okay, so these are the important things to remember about destructor. Okay, so now notice what we are doing in this destructor. We are printing that the destructor is called, and then we are simply deleting this data. Okay, so this should be array delete here. Okay, so we are deleting this data in this destructor. Okay, now you see what is happening here. You don't have to do anything. You instantiate the stack. Okay, you use the stack for whatever you are, let's say, reversing the string or something. Okay, and then you simply say return 0, nothing. Okay, and when you run the program, you will see that first the constructor will be called. Okay, then the reverse string thing will be printed. Okay, and then the destructor will be called. Nothing has been done here. So what has happened is that after main returns, okay, when the stack frame is being deleted, this particular stack variable S is also being deleted. Okay, at the time implicitly the destructor is called. Okay, and it has actually freed up this particular memory. Okay, and you can see the from the print statement that it has actually been called. Okay.
Sir,
Yes.
sir, suppose that we have this stack S in some separate function, and so when that function is returned, so will the same thing happen?
Yes, yes. So whenever this object S is destroyed, okay, the destructor will be implicitly called. Clear? So whenever, it's not just that, so we will see that suppose you create a stack object on the free store using new, okay, and then deallocate it using delete, then also the destructor will be called. Clear?
Okay, sir. Yes, sir.
So whenever any object is created, the constructor is called. whenever that object is destroyed, the destructor is called. So this is implicit. So you don't have to do anything. The compiler, when it is, creating the code for creating this object, okay, so the compiler furnishes the code for creating this object, right? So when you define an object, okay, there.
Sir, if we overload the destructor, then the lastly overloaded destructor will be called always, or there
You
will be
can
any preference.
put the destructor. Okay, why can't you overload the destructor? Okay, so let us. Yes, because it has.
It cannot have any parameters.
Yes.
No, sir, but we can define the destructor 2 times, because in the previous slide there was the destructor was defined 2 times. Once inside the class and
No. Okay, so.
okay,
here,
okay, sir, got it.
Okay.
Sir, if the object gets deleted when the scope ends, why can't we return it? I mean, can we return it?
If the object gets deleted, then you cannot return. No.
So cannot we return a object
Yeah,
that is
so how does it, so we have discussed this, right? So whenever we return any object from any function, okay, depending on the return mechanism, so if it is a return by value, then a copy of that object is created and that copy is returned. If it is a return by reference, then you should only return some object that you have created on a free store. Because if you return by reference an object which you have created on the stack, then the object is deallocated, but the reference is returned. So basically it's a problem. Okay, so the reference is pointing to a non-existent object. Clear?
so cannot we, sir, if we define a class that has similar to an array?
No, I did not understand.
We define a class which is actually an array. Like in that class we have an array element in star.
Yes, so this has a this stack has an array. Yes.
Yes, sir. So we want to initialize it in a function and we want to return it.
Yes. So you will return a so just hold on to that. We will come to that in a moment. So towards the end of it. But essentially, yes, you can do. And the way it happens is that this stack object S, okay, is returned by value, and returned by value basically follows the same mechanism. That is, a copy of that object is made and returned. Okay, there will be problems. I think what you are talking about is the shallow copy and the deep copy. We will come to that. Just hold on a second, okay? But the overall return mechanism is this, okay?
Okay, sir.
Excuse me, sir.
Yes.
So in the left program, why have we done in void dinit, we have done delete bracket data, but on the right side in the destructor only delete data.
No, this should be delete bracket data.
Okay,
This should be the array delete, okay? Okay. So so now you see. Okay, so what are the differences between destructor and a member function? Okay, yeah, so the destructor is a member function with this pointer. Okay, the name is what we already told. It has no return type, hence no return statement. Okay, it is called implicitly at the end of the scope or by the operator delete, like we discussed. Okay. And a destructor does not have any parameters because it is called implicitly at the time of deleting. So it does not have any parameter. Hence, there is a unique destructor for a class. Okay, and it cannot be overloaded. Okay. Okay. So okay. So now,
Sir, can you once go to the previous slide?
yes.
Sir, what is meant by this? Maybe called explicitly by the object.
Maybe. Okay. Okay. So, yeah. So actually, okay. So, yeah. So the destructor can be called can also be called explicitly by an object. Okay. Yeah. So, but that usage is very rare. Okay. So that is what it means. Clear?
So, sir, like a function, we will call it.
So for example, in this case, you are creating a stack S, okay, and then you're creating a new scope. You are creating a stack S, and then you are ending the scope. So at the end of the scope, okay, the destructor will be called.
Yes, sir, but we want to call it explicitly.
You want to call it explicitly, okay? Yeah. So yeah, so you can call it explicitly, okay? Why do
So
you
by
want?
writing this statement, stack colon colon, this one.
Yes, yes. So so by writing this, no. So yeah. So you can by writing this statement stack colon colon tilde stack ampersand s, you can call it. Yes.
Okay, sir.
May I, Professor Shorangshu?
Yes,
Just
yes.
to give a comment. First of all, if you recall our discussion, Professor Shorangshu explained the new operators, right? And you would recall that there were three variants were discussed. One was the new operator for a single variable, new operator for an array of variables, array new. And then he discussed a placement new operator. And you would recall that the placement new operator does not have a corresponding delete operator. And that is where you saw the example of a destructor being explicitly called. The point is, if you have an object, you can always call the destructor as if it is a member function. Right? So if you have the stack object, you can always call the destructor stack object S. Then you can always call the destructor as S dot tilde stack parenthesis. This is possible. There's no. The point is, if the object is a automatic object, right? It will come soon. You can see later in this module itself, Professor Shorangshu will tell you about object lifetime and where the object is. If the object is automatic, that is, it is in some block scope or function scope and so on, then the compiler by its behavior calls the destructor. Right? It does the job for you. So you cannot call that, you must not call the destructor for such objects, because then what it will mean that the destructor will get called twice, because compiler will call it anyway. But for an object which you have created in a context where the compiler will not call the destructor, like by placement new operator, you have to call the destructor. So this option is there, but it is extremely, extremely rare that you call the destructor. If it is automatic variable, compiler calls it. If it is dynamically allocated, then you will use the delete operator, where the delete operator in turn calls it. If it is a static variable, compiler will call it. Only if in cases like placement new, you will have to call it, right? So do not even think about calling the destructor. It will be a very, very bad practice, and you will get into several problems because the compiler finds out what needs to be done for doing the destruction. Is the point clear, or is there any other question?
No, yes, sir. Thank you.
Got it?
Yes, sir.
Sir, one more question. Sir, by the operator delete, like it will call like this delete s colon for this stack.
This slide,
Operator delete you will apply on the pointer to the object, right? That's your operator delete. So we have explained what it will do. From the pointer, it will first use that pointer to call the destructor so that the object gets properly cleaned up. And when that has been done, then further it has to do a deallocation process, which we have discussed in depth during new delete, right?
Yes, sir, yes.
So you do not directly call the destructor. That is the basic point, right? Thank you, Professor Shurangshu.
thank you. So, okay, so now we also discussed this point about default constructor. So, like we said, a constructor with no parameters is called a default constructor. Okay. Now, for when you define a class, okay, if you don't provide any constructor, okay, then the compiler supplies a free default constructor. Okay, so we saw this, right? So initially we were defining classes and we were not providing any constructors, but still there was a default constructor. That is, your class will be constructed. Okay, there won't be any initialization to that particular class. Okay, or at okay, and you basically the default constructor would simply allocate the memory for that particular object. Okay, but not the member data members will have garbage values. Okay, so this is the behavior of the free default constructor that is provided. Okay, but what happens is, if you provide a constructor, okay, whether it is a default constructor or constructor with parameters, okay, then what happens is the compiler does not provide any free constructor anymore. Okay, so now what happens is that default constructors of objects. So if you have a class which will always be initialized at the time of construction. Okay, so it will always be called with parameters. Then it is fine if you define constructors, okay, with parameter, but no default constructor. Okay, but the problem with that is that if you don't have any default constructors, okay, then you will not be able to define arrays of objects, and we will see this in detail in a minute. Okay, okay, so this is one thing. So the default constructor is special because it is especially necessary if you want to construct arrays of objects. Okay, and yeah, so again, if no destructor is provided, the compiler will provide a free default destructor. Okay, and the default destructor will basically not do anything. It will simply deallocate the memory of the objects that are there in the class definition. Okay. Okay, so here, yeah, so here we are sort of, yeah, we are showing the example of free default constructor. So you see, we don't have any constructor specified here. Okay, and we are creating the object, and the object is getting created, and everything is happening, and the free destructor is getting called. Okay. But now if you, for the same program, if you provide the constructor, okay, then it will use the constructor that you have provided. In that case, the compiler does not provide any default constructor, and you can see this, that it will indeed print the print statements that you have given in the constructor and the destructor. Okay.
Sir,
Yes.
sir, if I here define a constructor with 2 parameters, but I still initialize it using just complex C without giving any parameters, will it call the default constructor?
No,
Like,
default.
can I call it constructor overloading?
No, there is no default constructor in that case. So if you only define a constructor with 2 parameters, okay, and let's say you have also not defaulted them, okay. So if you default the values, then of course it will call the defaulted version of that constructor that we have seen already, right?
Sir, I'm not defaulting the values.
You are not
Just 2
defaulting the values,
parameters.
and you are also so then there, that's what I just mentioned, that then this particular class will have no default constructor. Okay, so free default constructor will only be provided if there is no constructor. Clear?
Okay, sir.
Sir,
Yes.
sir, like destructor, any destructor that we define is a default destructor, right?
Yes, yes. Any destructor that you define. So yeah, so yeah, there is only one type of destructor. There is only one destructor that an object can have. If you define as destructor, then there won't be any free destructor. Okay. If you don't define a destructor, then the compiler will provide a free destructor. Okay. Okay.
Sir, in one of the previous slides, where you had used dinit function, you said it is bad practice because it won't be deallocated. But now, if we have default destructors, then what does it matter? Like, won't it always be deallocated?
No. Like I mentioned. And so if you go back to this, let me go back to this example. Okay, so just give me 1 minute. Yeah, you see, this will be yeah. So let us see here, right? So if you don't do, is this no? This is, just give me 1 minute.
Oh, sir, I got it, sir. That new.
So it was on later slides.
That won't be deallocated.
Yeah.
Okay,
yeah, this one. Yeah. So yeah. So everything will be deallocated except the new thing that you have done here. So in the constructor, you have done this new cat 10, right?
Yes, sir, I got it.
Okay.
Thank you.
Okay.
Does the destructor deallocate the memory for the static variables only, or the dynamic allocated variables also?
We will come. So how see automatic, static, and dynamic we will come when we are discussing object lifetime. So just hold on to that. Okay. So let us go forward. Just hold on to that question. We will come to that. Okay.
So sir, if we write dinit function, then it will remove only dynamic memory. It won't. We should not. Is it?
No, I'm not able to understand your question.
Sir, you said like if we use dinit function, it will remove only dynamically allocated memory.
Yes, in that particular application, the way I had defined dinit function, it was deleting the dynamically allocated memory.
So the destructor also does the same, right? Along with deleting the char star.
If you define the destructor that way.
Okay.
Okay. Okay, so okay, so now you see, okay, so now we are discussing a concept which is called the object lifetime. Okay, so what is the object lifetime? Okay, so basically, so suppose you have, let's say, this particular application on the left that we are showing. Okay, and it is creating this. So there is a, so to the right, I'm showing you the class code. So basically the class is defined here. Okay, and here to the left, I'm creating this object C of type complex. Okay, which has been defined here. Okay, so this C is now object. Okay, C is a variable which denotes object of type complex. Okay, so the lifetime of the object is basically the time from its construction to the to the time of its destruction. Okay, so just think about how this application is running. So this application may be running in a broader context. And now in this particular application, this myfunc has been called and myfunc is executing. Okay, so this event E1, what it does is it creates the stack frame for this myfunc. Okay, so the memory for the object C has been created in the stack frame. Okay, so this is the event E1. Okay, then the event E2 is basically when you define the object, which is being done here. Okay, where the object complex is being created. Okay, so you pass the control to this. So you basically create this object C. Okay, and then in order to create this object C, you call this this function. You can think of it as the member function, which is the constructor function, which is complex : complex ampersand C. Okay. Okay, so by this time you already have the memory and you already have the address of the object C. Okay, now what happens is so inside the constructor, the first thing that happens is that the initializer list is processed. We'll see how in some time we will see how exactly the initializer list is processed, but essentially the initializer list is processed. So this is the event E3. Okay, where the initializer list is processed. Okay, after the initializer list is processed, okay, now the object lifetime starts. So this E4 starts from the beginning of the constructor. Okay, so the object lifetime starts from the beginning of the body of the constructor, to be more specific. Okay. Okay, so this marks the start of the object lifetime. Okay, and after that, whatever happens, you can think of it as though the object is already alive. Okay, so the objective is already active. Okay, and then you do the object use. So basically, event E5 is that you use the object. Okay, and E6 is you call some member function. So all this while the object is alive. Okay. Then you come to the return statement of this myfunc. Okay, so at this point in time, okay, the destructor is called. Okay, so just before the deallocation of this particular object, I mean the stack frame, and if the stack frame has to be deallocated, all the objects that are created in this stack frame has to be deallocated. Okay, in particular, this particular object C will be deallocated. Okay, before that, the destructor is called. Okay, so before deallocation, so event 7 is basically, you can see that yeah, so basically the destructor is called after the return statement. Okay, so yeah, okay, and then the destructor will execute. Okay, after the destructor, till the destructor is executing, okay, still the object is alive. Okay, after the destructor has executed, okay, that marks the end of the lifetime of the object. Okay, and at the after that, basically the memory for the object C is deallocated along with the entire stack frame. Okay, so this is the whole. So this, from the start of the constructor to the end of the destructor, is called the lifetime of an object. Okay. Okay, so so we have already discussed, just describing. So these are the execution stages that you have to do the memory allocation and the binding. Okay, so so basically, so the binding is basically the assignment of the address to the variable. Okay, you can think of it like this. Okay, so you have to do the memory allocation and the binding. Okay. Then the constructor call and execution, objectives, destructor call and execution. So all the blue part is the lifetime of the object, and then the memory deallocation and debinding. Okay, so this is how the execution proceeds. Okay, okay, so yeah, I think all this we have seen. So yeah, so you can understand this, that basically the execution of the constructor must follow the memory allocation. Okay, and the execution of I mean the memory deallocation or the execution of the destructor must precede the memory deallocation, because once the memory deallocation is done, the object is no longer, the memory that the object had is no longer accessible. Okay. And for built-in types, there is no explicit constructor or destructor, of course. Okay, so the lifetime for built objects of built-in type, okay, is basically from the time of the definition to the end of the scope. Okay, so this is for the automatic variable. Okay. Okay, yeah, so this is an example which basically describes the object lifetime. Okay, again, the complex example. So I will skip it in the interest of time. If you have any questions, please go through it and you can ask me. Okay. Okay, yeah, so so here again, an important example is that when you are creating an array of objects, okay, one thing you will see is that, so you are creating a array of objects here. Okay, so of size 3, the constructor will be called 3 times. So you can see that the default constructor will be printed 3 times because we have given the print statement. You can see that it will get printed. Okay. And now, so what you have done is you have okay, so this is about the constructor. At the time of destructor, okay, again 3 destructor will be called, as you can see, because 3 objects are being destroyed here. Okay, and they are, so the interesting thing is that they are being called in the reverse order. Okay, so first the last object that was created, this C2 is being destroyed, then C1 is being destroyed, and then C0 is being destroyed. Okay, so okay, yeah, so this is how so this is another interesting experiment.
Sir?
Yes.
Sir, if I have a constructor with two parameters in which the parameters are not being defaulted, I cannot have an array of objects, right?
Yes,
or can I have?
you cannot have. That's what we just said, right? So you need to have a default constructor in order to define an array. Okay. Okay. So okay. So here now okay. So so up till now we were talking about the lifetime of so these examples were talking about lifetime of automatic objects, which is the object that is allocated on stack. Okay. There is a second type of object, which is the static object. Okay. Now the lifetime of the static object, okay, starts before the main is executed. Okay, so just look at this particular program. Okay, so here we are defining this global object. Okay, which is complex C. So this is the definition of the global object. Okay, and then okay. So, and then you are having this another complex object that we are defining inside. Okay. So you see the constructor. So just after entering main, we print main starts. Okay. Okay. And then we do many things. Okay. Now you see, even before entering main, the constructor of the global object is being executed, and you see this statement being printed. So before the start of the main, all the global objects are initialized, and their lifetime lasts, as you know, throughout the lifetime of the entire program. Okay. Similarly, at the time of destruction, you see that when the main exits, the object D is being destroyed. So destructor of this 2.4, 0, this destructor is being called when main exits. Okay. And then the destructor of this global object C is being called. Okay. Which basically is the last thing to happen in this program after the exit of the main. Okay. Okay, so this is about the lifetime of a static object. Okay, static or global object. Okay, now here the other thing is that you are so suppose you are now creating a dynamic object. So dynamic object, as you know, are the objects that are created using the new keyword, either the normal new or the array new. Okay, so you can use both to create the create objects. Okay, now here, as you can see again, so the first one, the constructor is being called first. Okay, and then there will be two constructor calls for this array, and this will be the call to the default constructor. Okay, so we have already defaulted it here. So you can see that 0, 0 and 0, 0 is being called. Okay, and then finally the and then there is this object that another complex object that we are creating using the placement new operator in this particular buffer. Okay, and this is the constructor call for that. So basically the constructor, the objects are created one after the other in the order that they are dynamically allocated in the program. Okay, now and then again, for that, at the time of destruction, you see we are destroying the PC object first. So the destructor for the PC object is being called first. Then we are doing array delete for this PD, which was defined second. Okay, So the destructors for those two are called. And then we are calling this destructor for the PE object which we allocated in this using this placement new operator. Okay, so the destructor of that is being called. So here basically the object lifetime is begins with the new call and ends with the delete call. Okay, so it is not necessarily in some specific. So the order is when you call it in the program. Okay. Okay, so with that we end. So yeah, so objects are initialized by constructor. Constructor can be parameterized and overloaded. Objects are cleaned up by destructors. Compiler provides a free default constructor. Yeah, so this is so objects have a well-defined lifetime spanning from beginning of the execution of the body of the constructor till the end of the execution of the body of the destructor. Okay, and yeah, so memory of the available for an object must be available throughout the lifetime, that is before the construction and only released after the destruction. Okay, so with this we conclude this particular topic. And any questions?
Sir?
Yes.